Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is integer break. So you are given a integer n, you have to break it into sum of k positive integers where k should be greater than equal to 2. So at least you should break it into a sum of two positive integers, and you have to maximize the product of those integers. For example, 2 can be broken into 1 plus 1 and the product will be 1, and here when n is equal to 10, 10 can be broken into 3 plus 4, and product of these three numbers will be 36. So we have to maximize this product. Okay, so let's see how we will be solving this problem. And the constraints are that n will vary from 2 to 58. So what we will do is we will be using a greedy approach. Uh, let's say I break n into two parts. Okay, for now consider that I break n into two parts only. Uh, when these two parts will be equal, let's say the product is defined as something like this. Product is let's say the first part is part 1, so it will be nothing but part 1 into n minus part 1. Okay, since n should be sum of part 1 and part 2, so this will be your part 2. Now when this particular product will be maximum, what should be the values of part 1 and part 2? So the part it can be observed that part 1 and part 2 values should be equal to n by 2. Only then your product will be maximum. This will be the case when, let's say, your n is a even number, it is divisible by 2. In case n is a odd number, then your part 1 and part 2 will be n minus 1 by 2. Your part 1, and part 2 can be part 2 will be n minus n plus 1 by 2. Okay, you can take any number. For example, let's say we take 8. So maximum can be achieved only when 4 into 4 will be done. If you do anything except this, let's say we do 1 into 7, not good, only 7. Then let's keep increasing this one and decreasing this one. Then you can observe that let's say 2 into 6, 12. Then 3 into 5, 15. Then 4 into 4, 16. And then 3 into 4, it will be 5 into 4. But 5 into 4 cannot be equal to, is not equal to 8. So we will stop here, as your sum exceeds these parts should sum equal to 8. Okay, then this is the maximum indeed. So this satisfies that these two observations are correct. Basically it is a single observation. The cases are different. When n is even, here n will be odd. Okay, and so if we multiply let's say in even case, for even case, part 1 into part 2 should be at least greater than equal to n. Okay, and maximum value, and similarly uh, for even what was the formula that we derived by observation, n by 2 into n by 2 should at least be greater than n. So n should be greater than equal to 4. Okay, and in the even one, in the odd case, it was this. So n, it will give us n should be at least greater than 5. So whenever your n will be equal to or greater than 4, you can divide it into two parts. So this will be your observation. Whenever your n is greater than equal to 4, then it can be divided into two parts. Okay, uh, except that dividing n into two parts will not give you maximum answer. So now what you will do to solve this particular problem is, so n should be at least, the parts that will not be divided will be 1, 2 and 3. Okay, so what is the maximum of these? 3 is the maximum indeed. So we will try to extract as many as 3's from n, and rest, which is whatever is left out, will be multiplied to the final product. Okay, this will give you the final product. So let's try to solve the problem. Let's try to implement our solution. If let's say your n is equal to 2, then you will return 1 in this case. And if let's say your n is equal to okay, and if n is equal to 3, then the maximum that you can get is 2. So we will extract as many as 3's as possible. From n. Okay, now while your n is greater than equal to 4, or say greater than 4, then you will keep performing the following action, which will be let's define the maximum product. Okay, then your n will be decremented every time by 3, since we will keep extracting 3 from n, and your product every time will be multiplied with 3. Okay, and then your max product will be multiplied whatever is left of your n. Okay, and then you will return your max product. Let's try to submit. It's getting some error. The max product cannot find symbol. Okay, we have done some spelling mistake. Let's try to submit for sample test cases first. As you can see, it's getting accepted for these two at least. Now let's try to submit it. As you can see, it's getting accepted. So I will explain once again. So the logic was pretty simple. You try to split your parts into initially into two parts and see how we will be able to get maximum product. So maximum product can be achieved in these two cases for even and odd n. Okay, and these two cases. So what we will do is we will consider n for a break when product reaches greater than n, greater than or equal to n. Okay, then you will consider breaking your current value of n. So for part whenever your part 1 and part 2 product becomes equal to or greater than n, then you will do a break. It will be the most optimal case to do a break, to break n further. Okay, and that's pretty much it. After solving these two equations for even and odd, we came to know that whenever n is greater than equal to 4, we are able to do a break. So whenever your n is greater than equal to 4, then it can be divided into two parts, which will maximize your product. The final product, maximize the final product. Okay, this is the observation. And so out of these three numbers, which are lesser than 4, obviously, we will take as many as 3's that are possible, and then we will multiply the rest, whatever is left out of your n will be multiplied to the final product. So that's the logic and the approach, and the solution will be available in 3 languages: C++, Python and Java. So thank you for watching. If you are still having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer them. Thanks.